Good afternoon, everyone. My name is Victor Gensini. I'm an assistant professor of meteorology at the College of DuPage, and this weather briefing is going to focus in on the potential for accumulating snow, specifically across northern Illinois. So let's jump right in here to this discussion. Current temperatures across the United States, we're at 33 at O'Hare, 35 looks like near Champaign-Urbana, 43 downstate near St. Louis. Generally speaking, the warmth is tied to the Gulf Coast. We have temperatures today in Brownsville, 74 degrees Fahrenheit. Go over towards Florida, Miami, Orlando, they're sitting in at around 70. So we will see these temperatures, specifically these temperatures up here in the northern plains, the teens that we're seeing sort of ooze into the northern portion of the Midwest and the southern Great Lakes, and then eventually maybe more of a cold push as we get into middle to late next week. If you take a look at the dew points, we're generally dry also across this area. With lower temperatures, we typically see lower dew points, but pretty high dew points here in southern Texas. We're in the mid to low 60s and widespread 50s actually as well in central Texas. But you can see the sharp change between these higher dew points here in the 50s and in the 30s as we approach the areas towards Oklahoma City. Generally speaking, right now across the Midwest, our dew points are in the upper 20s or lower 30s. And they'll probably maintain those sort of values as we move into the next 24 hours as our sort of moisture content begins to increase with this oncoming snowfall that we're expecting. Actually, we're about 8 degrees warmer than we were yesterday at this time in Chicago. You go over to places like Des Moines, they're about 17 degrees warmer than they were yesterday at this time. So actually, in terms of a relative sense, a little bit warmer than we were yesterday, but you can see that sharply and quickly changes as you get into places like North Dakota and Montana, where they're seeing potentially double-digit decreases in their temperatures. And as you can imagine, we'll be starting to see some of these values, especially after our snowfall on Monday, as our winds sort of change out of the northwest direction and begin to advect some of that colder air in towards our location. Just take a quick general look at snow depth across the country. The main headline here in the past week or so is this big blizzard system that influenced the northeastern United States. You can see snowfall totals in that region are still actually in the 20 to 30 inch range across places like Boston and into Portland, Maine. But across Illinois, in this swath that we're actually going to be experiencing snow, so generally in the I-80 corridor, not much actually here on the ground right now. We can take a look at that invisible satellite in just a second, until you move into places like Pennsylvania, where they actually have about 10 to 20 inches of snow already on the ground. So definitely going to be adding to these totals over the next 48 hours. This is an upper air map from this morning at 500 millibars, so we have 500 millibar heights on here, contoured in black. We have the upper air observation stations. We also have ice attacks contoured, so lines of equal wind speed. And a couple of just important things here to note on the 500 millibar map. Sort of a jet speed maximum in this area where we don't really have great observations over Mexico, but see a little bit of enhancement of the wind speeds there. This is actually associated with an upper level low that's sort of been spinning over the Baja the past couple of days. General ridging into the central plains, and we're going to see that actually forces a nice 850 millibar high over places specifically centered over Mississippi and Alabama this morning. So general ridging here, sort of the top of the roller coaster, if you will, going down into more broad troughing off the coast of the eastern United States. One important thing to note here on the 500 millibar map is this slight little bend in the height field over Wyoming and Montana this morning. This is actually what we call a shortwave trough. You can actually see that quite nicely on the Riverton Wyoming observation, and then going over to Rapid City, South Dakota. You can see how the winds sort of change direction there from northwest to more of a westerly direction. This is actually in response to the shortwave trough that we're seeing move through this region right now. We'll take a look at that in just a second on water vapor imagery. How have our heights changed in the past 12 hours? About 100 meter height falls with the approach of this shortwave trough, some building of the ridge in the east, and you can see how our height fields have changed with this upper level low in the Four Corners and Mexico region. It's been slow to move over the past 24 hours. Otherwise, nice negatively tilted trough up here in the northeastern United States. That'll be departing as this ridge builds and allow this sort of shortwave trough area, these height falls, to begin to advect into the western Great Lakes region. On the 850 millibar map, There's our high that we just mentioned over the Mississippi, Alabama, generally over the Gulf Coast region. So we expect our clockwise flow around the high pressure system. So if you sort of follow the wind barbs here, we get this clockwise-like circulation. And to the west of that high pressure system, this ridge, we see some really nice temperature and moisture advection, especially over central Texas and into the Oklahoma area, and even actually getting up into Missouri by now. This was at 6 o'clock this morning, this particular image, because it's from the weather balloon launch. So sort of the squeeze play going on here. We have the upper level low over the Baja. We have the upper level ridge. Again, this is at 850, so a little bit lower than upper levels, but generally speaking, we see some nice forcing going, some nice wind speeds, just nice temperature and moisture advection across the central plains at 850 millibars. Sort of some 850, you could see some cyclogenesis going on here in response to this wave, and it's really going to show up once it gets over the plains here this afternoon, and it's already showing up now, but this was from this morning. So if we sort of take a different approach to look at this, this is 850 millibar theta E. The blue lines here represent generally the wind flow pattern, so you can see the nice theta E advection. We have sort of higher values being advected northward into the central plains, and even have positive theta E advection when you get into places like Illinois and Indiana as well, sort of on the top of this ridge. Moisture here, this is the mixing ratio. See, the origin of the moisture actually for this particular system is actually of Pacific moisture origin. This is not typically what we see with large snowfalls in Chicago, in Indiana, in Ohio. We actually typically look for big low pressure systems that are coming out of the Texas Panhandle and hooking northward, advecting Gulf of Mexico moisture northward. It's just a little bit different of a system in terms of its trajectory. It makes it a little bit interesting to forecast for, because typically when you get big snows across the Chicagoland region, it's the 850 millibar high is positioned much further to the east, and these systems sort of come out of the Texas area, hook northward, and generally cross through around St. Louis, and then on the northwest side of those low pressure systems you get this big swath of accumulating snow in what we call the deformation band. And this is a totally different type of system that we're seeing with this. You can see the streamlines sort of showing a counterclockwise circulation here at 850 where we saw that on the map. As this moves out into the plains, this is actually going to be the main weather maker rather than sort of having an origin down here near Amarillo, Texas. Here's the precipitable water values from this morning's soundings. You can see again most of the moisture source is actually of Pacific origin, with values approaching 3/4 of an inch of precipitable water as we get to places like central Kansas. And I think we need to talk about this a little bit more because it actually goes into possibly a little bit of our forecasted snowfall and specifically the liquid equivalent amounts that we're going to see from the models here once we get towards the edge of this discussion. And one of the main concerns that I have is exactly the amount of quantitative precipitation forecasts that the models are putting out relative to the precipitable water that was shown in this morning's sounding. So we will sort of talk about this and come back to it again. But again, you can sort of generally see a nice south-southwesterly flow in the surface to 400 millibar mean layer, advecting higher values of precipitable water northward. And again, this will be sort of the main source of moisture as we go into the next 24 hours from our snowstorm. Here's our water vapor imagery this morning with RAP 500 millibar heights, winds, and also RAP analyzed absolute vorticity on here. The absolute vorticity contours shown in yellow dashed, and the sort of maximums here as denoted by GEMPAC as these yellow X's. And so a couple of things to note out. Here's that Baja low that we talked about, sort of big, nice, closed upper level low. On the east side of that, we have nice southwesterly flow and all of our moisture and thermal advection that we talked about on the 850 map. Here's our sort of shortwave trough that we analyzed on the upper level map that we were talking about, that slight bend in the height fields. That's moving into Montana right now. As that gets into Nebraska, especially by the time it gets to Omaha, we're going to see quite a bit of precipitation blossoming over northern. We've already seen a little bit, but even much more in the spread of that will move into northern Missouri, western Iowa, and eventually the Chicagoland region. Probably by around 7 to 8 o'clock tonight is really when we'll see a lot of this precipitation begin to get to the Chicagoland region. So pretty cool water vapor this morning, and again, not sort of exactly what we would see with these bigger systems. We certainly would see a low coming out, but more of cyclogenesis in the Texas Panhandle area. Actually, our low is going to be coming up here almost in a clipper-like sense, moving out over southern Alberta and into Montana right now. This is a cross-sectional analysis from this morning's weather balloons. This is actually taking from cross-section from Del Rio, Texas up to Bismarck, North Dakota. So you can see here 72764 corresponds to Bismarck, so Bismarck is on your left. So as you go from left to right on this image, you are basically going from south to north. Red lines are theta, yellow dashed lines are theta E. We also have mixing ratio as these blue, or the green lines on here, excuse me. So you can see the higher mixing ratio values as you go further south, especially once you get down here near Del Rio. We have upwards of 6 grams per kilogram of moisture in terms of mixing ratio. So the cool thing to note is the sloping of these theta lines. So we're just going to focus in on the theta lines here for just a second, the red lines. The first theta line that doesn't intersect the surface looks to be probably around 290. So 292, the 292 Kelvin surface is probably not intersecting the ground. So that would be a good, if we're doing sort of an isentropic analysis, the 292 or 290 surface would probably be pretty representative of a parcel that wouldn't be originating from underground. It'd probably be originating from right above or at near the surface. And since you have southerly winds over a majority of this cross section, you can basically imagine that as a parcel moves along this constant theta surface, especially once it gets to about the 72567 or 72662, which is probably the Omaha sounding, the parcels would generally be sort of coasting along at about a constant pressure value. So there wasn't real great isentropic lift this morning, but if the parcel was saturated and it was taking a constant line of theta E, you could see that it would be going into much lower pressures. In this case, it would have to be increasing in altitude. So as we would follow this theta E surface, especially right around in this region, which again is probably over central Oklahoma into most of Kansas area, and then finally the Bismarck observations there. The 622 might be Aberdeen. So getting really good isentropic lift showing up, especially for a parcel that is saturated across most of the Central Plains. And so we're going to take this a little bit different. Now we're going to take this 292 surface, we're going to sort of flatten it out and analyze the pressures on that surface. And so what you're looking at here is an isentropic map of the 292 Kelvin, basically flattening out this as a constant surface now, and then analyzing pressures on that surface. And so you can see the higher pressures down here. And so when a parcel basically moves at an angle along these surfaces, it has to be rising, because if it's going towards lower pressure, that means the parcel has to be ascending in altitude. So one of these cool ways to look at this is winds that cross these isobaric isobars on this particular map. If they cross these surfaces at a strong angle, like they are here across Texas and even into places like Kansas, this is a really good example right in this region of isentropic ascent. As these parcels, especially, you can see here 40 knots showing up. So it's good, strong, almost 90-degree perpendicular flow across these isobars with high mixing ratio values. And you can see we're almost saturated, 95% relative humidity in a lot of these areas, 90%. So the good isentropic analysis and ascent this morning was across western Texas, getting into central Kansas, and then up into here in Nebraska. So the cross-section probably wasn't the greatest representation of exactly where this is occurring right now. Most of it was just to the west of that. But I bet the 0Z RAYOB launches, the weather balloon launches at 0Z, 6 p.m. tonight, will show some really good isentropic analysis across the Central Plains. It's something to keep an eye on as this precipitation continues to blossom. Speaking of the precipitation, here's our current radar imagery. In an animated sense here, lots and lots of precipitation showing up on radar. We have some snow going on to the north and then transitioning along the I-70 corridor to mostly rain. And so this is the sort of effect of that isentropic ascent in the approach of this short wave that's moving out of the Dakotas, and also this big upper level low that we have out to our west. And so the bottom line here is this is predominantly driven by isentropic ascent, driven by, again, warm air advection and a little bit of vorticity advection, but that will mostly become later on. This is right now. All of this rainfall is a function of isentropic ascent from parcels that are originating in southern Texas. Zoom in a little bit on our forecast area, what's going on the surface maps here. This is just a zoom in. We'll take a look at the broad surface analysis. I think I just did these out of order. Yes, let me switch these. Here's our surface analysis. Here's where we were about 24 hours ago. How have things changed in 24 hours? If I loop through here, you can see yesterday at this time we had a high pressure, relative high pressure at the surface over northern Missouri. You can see how that sort of vacates. By yesterday afternoon, we had some fairly sunny skies across Chicago, and you can see the return flow around the high has already started at that time. Moving in overnight, our high pressure, if I could show you, is probably be right now sitting over the eastern Tennessee Valley area, and now we have really strong southerly flow across the Central Plains. 15-20 knots depending on where you are. You can see the rain-snow cutoff line right now is right in about that I-70 corridor. The two dots here on the surface map indicating rainfall across most of Oklahoma, Kansas, and even to Texas, where the temperatures are in the upper 30s to 40s. So in response to that upper level wave that's approaching out of Minnesota, you can see some cyclogenesis getting going here, the formation of a low pressure system. This will become well more better defined as we go into the evening hours. And this is basically what we'll watch in terms of a track. Exactly where does this low pressure track across Illinois in order to create a swath of accumulating snowfall. So let's zoom in just a bit here. We can see some still ridging going on across Missouri and Illinois. We're still under the influence of this high pressure system, so we haven't even begun to basically feel the sensible weather from the actual quote-unquote winter storm just yet. Zooming into Chicago here, 36 at Midway, 33 at O'Hare, 33 at DuPage, 31 out at Rochelle, and generally speaking, 30s across most of the region. There will be a little bit of a concern about the onset of the precipitation, whether or not that will be in the form of rain or snow. You can see the temperatures downstate now actually still relatively warm, hanging on at 36 and 35 respectively at Illinois Valley Regional Airport in Lakin, Illinois as well. Light winds just out of the southwest, and as this storm really gets cranking, you're going to see these winds shift from the south and then eventually almost an easterly direction as this low pressure system passes to our south. So watch the wind directions change here in the next especially 12 hours and then 24 hours. They're going to take this south dive and then eventually a strong easterly fetch, and then even northeasterly as we get into the height of this storm by tomorrow afternoon. Here's our visible satellite image. Generally speaking, lots of high clouds, some cirrus streaming in from the west and the southwest, and you can see the cloud cover is really only going to get more enhanced. If we take a look over towards Kirkville, Missouri, or southwestern Iowa, even the Kansas City area, those areas socked in with clouds here this morning. Little bit of snow there you can see on the visible satellite this morning, the white at the surface that's not moving, and certainly the much greater snowpack that you have as you go further east on I-80. So this is going to be primarily a significant event for the I-80 corridor, as we're going to see here in the models. That's sort of going to be the best combination of cooler temperatures to support greater snow ratios, but also just the general track of the low pressure system. So as the low tracks, you're sort of looking at, generally speaking, on a sort of a rule of thumb, an area north and northwest of that surface low is generally sort of right where you get the sweet spot for snowfall, and that seems to be lining up right now between the I-80 and the I-88 corridor in Illinois, and certainly as you move into northern Indiana, these sort of areas downstream and east of that are going to be sort of probably the areas that end up with the most amount of snowfall. So here's the forecast from the Weather Prediction Center in terms of liquid equivalent. So this is basically just forecasting if you took all the snowfall that's going to fall over the next couple of days and sort of melt it down, how much would you have in liquid? The highest value showing up right around the I-80 corridor here with 1.4 inches of QPF. QPF stands for Quantitative Precipitation Forecast, so just getting you an idea of how much liquid equivalent is forecast to fall. This is for days 1 through 5, but we're not really expecting anything significant after this storm, so we can sort of just look at this as a 5-day total. And you can see actually areas that got in on that blizzard last week are probably going to get some snow out of this as well. In fact, I looked at Boston just for the heck of it, and they actually look like they would probably get a solid 8 to 10 inches out of this system as well. I think the values that are going to be most impressive actually might end up over extreme northern Indiana, and northwest Indiana might actually see the most amount of particular snow from this event. So that's the sort of subjective guidance from the WPC based on all of the models that they're looking at. Sort of gives you another forecaster perspective to sort of check yourself against some of the values that you're seeing. Again, it won't fall as liquid, or at least most of it, unless you're down here south of St. Louis or maybe the Springfield area. Most of this up here is going to fall as snow. So if we take a look at the probability here, take a look at a bunch of different models together, get an idea from the WPC is what they're expecting for snowfall. This is the probability of seeing at least 6 inches of snow, so greater than or equal to 6 inches of snow. As we walk through the time frame here, here's by 18Z Sunday, sort of this loads up here, and then overnight, this is about 7 p.m. on Sunday, so right about Super Bowl time here. A greater than 95% chance of anywhere sort of north of Lincoln, Illinois, as far west as southern Iowa, as far north as the Illinois-Wisconsin border, and then continuing certainly right on through places north of Indianapolis, basically the north half of Indiana, and even into western Ohio. This entire area, in terms of the WPC perspective here, seeing a very high chance for at least 6 inches of snow. In fact, if you bump this up to 8, you can see the corridor right around the I-80 area really shows up nicely as seeing really high probabilities of at least 8 inches of snowfall in that particular case. I'm going to go back down to the 6 here just to show you this broad expanse. This storm really seems like it's going to wind down by late Sunday night and overnight into Monday morning. So we might even see the chance for some lake effect behind that. We'll talk about that in just a second. So that's the forecast from the WPC. The local offices here, specifically the Chicago and Davenport offices. Let's take a look first at the Chicago office. Here's their weather graphic. Most of northern Illinois, again, seeing pretty consistent with those WPC graphics here. Some good collaboration going on between the offices in Illinois, specifically Romeoville and in the Davenport office. You can sort of see what's going on here. Accumulating snow starts this evening. Snowfall rates a ½ inch an hour, maybe an inch an hour. I'm thinking actually in the height of the storm. Blowing and drifting snow Sunday night and into Monday morning. The Davenport office, sort of same thing here, high confidence. This is sort of a really high confidence event right now. The models are really, all the different types of models that we have are converging on a solution that's pretty consistent with what I'm seeing. And I think this is sort of, I don't want to say a slam dunk forecast here, but I think this is becoming a really high probability event. Not necessarily in terms of impact, because the snow is not going to be falling at a 2 to 3 inch per hour rate, which is really where you start to see problems with travel. But this is going to be a long duration event. It's essentially going to be snowing for all day Sunday, certainly, and although it's going to be, the snow will be falling at a rate of maybe a ½ inch to an inch an hour, so not generally high impact, but long duration. This is why it's leading to some of the higher totals that we're seeing here. So quads, in terms of their amount, again, I could probably stretch that 10-inch range through the I-80 corridor, and especially the areas near the lake that might see a little bit of a lake enhancement from this particular system as well. Just from an ensemble perspective, let's take a look at where the low pressure system is going to track. Again, from all the different models here, pretty good clustering. Some have a little bit further south, some outliers here, but generally speaking, most of them think by the next 24 hours. I think these are 12-hour time steps. Yeah, 12-hour time steps as to where we're going to see the forecast cyclogenesis. So by 0Z on February 2nd, so basically looking at tomorrow evening, this is going to, all the models sort of converge on this solution of having a low pressure system around 1,002 millibars sitting at the tri-states between Indiana, Ohio, and Kentucky, sort of generally in that area. And so the mean track here from the Weather Prediction Center generally takes a really nice track, if you like, accumulating snowfall in northern Illinois and northern Indiana. Okay, let's finally get into some individual model solutions here. I'm not going to spend too much time on this because generally they're most in agreement here. I'll just kind of look at the NAM, and we'll take a brief look at the NAM, the 4-kilometer CONUS nest, or the higher resolution here. I'm just going to focus in on the floater sector here for Rockford. We'll take a look at some of the precipitation fields. We can compare some different model runs and the vorticity. I can sort of show you that. But here's the onset of the precipitation. So we have isobars on this map in the cyan. We have QPF, 3-hour QPF shown in the shaded colors here. So higher QPF values with the darker greens, and as we get possibly even to the yellows. We have 500 millibar thickness on here. Generally speaking, the 540 line, the 5,400 meter line is a good cutoff between rain and snow. That will probably also hold true for this particular event, so nothing new here. The onset of the precipitation across northeast Illinois seems to be somewhere right in the 6 to 9 p.m. time frame across most of the region, and I think the Conus Nest sort of agrees with this as well, with the height of the snowfall really becoming early Sunday morning. Specifically probably around the 7 a.m. time frame, I think is really going to be snowing at a pretty good clip across most of northern Illinois. You even get, you can see the track of the surface low actually pretty broad right over St. Louis area, very similar to what the WPC had. And then this storm, you can see the winds here switch out of northwest with the isobars. You know, I wouldn't say near blizzard conditions, but I wouldn't be surprised to see some gusts in there to 30, maybe even 35 knots. That's going to probably be stretching it at this point, given the track of the low and the strength of the low. So I'm not expecting any sort of blizzard-like conditions, but you know, a pretty moderate snowstorm for most of Illinois and well, I guess north, if you're north of sort of the I-74 corridor, certainly. But you know, northern and central Illinois, sort of where this discussion is forecasting it on, this is going to be a pretty good clip of a storm for a lot of people across Illinois. And then the storm sort of departs here. You can see the precipitation end pretty abruptly, right in the, probably say maybe 3 a.m. to 6 a.m. time frame on Sunday is sort of where we'll see the back edge of this precipitation. And maybe a little bit of lake effect after that. Although it's still sort of to be determined exactly how much lake effect we're going to get in terms of a fetch, and where the highest lake effect totals might end up, if they're going to be in northwest Indiana or if they'll actually be closer to places like Midway. So let me pull up the Conus Nest here. I'll show you something interesting. Let's just go to the floater sector to show you simulated reflectivity here, sort of a model depiction of what the radar will sort of look like. It's just at hourly intervals. You can see the snow sort of begins to overspread the area. A little bit of a toss-up in the model is if the precipitation will actually start as snow or if it'll be rain downstate. I think here in northeast Illinois, northern Illinois, we're not going to have any problem starting as snow. This is a pretty abrupt saturation. If you take a look at the forecast models, there's not really much dry air hanging around, so top-down saturation should occur pretty abruptly sometime between 7 and 9 p.m. across most of northeast Illinois. And then you can see generally here, you know, not any ridiculously high DBZ values out of the models for the snowfall. So again, a pretty moderate rate of snow, moderate to probably low rate of snow. But you can see just the duration here. So we're still all the way through 21Z tomorrow, Sunday, and you can see some pockets in here, so maybe some dry air to deal with on the north side. But generally speaking, this is going to be a pretty wide swath of snow. And then at the end here, the model may be kind of an idea of some sort of lake effect band setting up. So we'll have to watch that as the winds turn northeasterly and come down the spine of Lake Michigan. Maybe some enhanced snowfall totals close to the lake, places like Midway Airport, Gary, Indiana, Porter County, LaPorte County in northwest Indiana might get in on this lake effect as the low pressure system departs out. Here's an ensemble look at some snowfall totals across the area. I started with DuPage. Our official forecast on Friday afternoon when we sent it out to the college was 7 to 9 inches, and I don't think I would change that forecast at all based on what I'm seeing right now. The liquid equivalent totals, again, here all the models, the GFS and the NAM and the Conus Nest, sort of coming into agreement with somewhere right around an inch of QPF. If you take that at 10 to 1 face value, I think the ratios on average from this event will probably be a little bit higher than that. But I always get a little bit leery when these systems are not DFO bands coming out. Exactly how much QPF are you going to get with Pacific moisture is always the sort of question. And with those P watts at 3/4 of an inch right now, I'm kind of siding a little bit with the Weather Service on the low end of this, and I wouldn't be surprised the next generation of models here come in to be maybe sort of around this 0.8 area, averaging, you know, somewhere maybe around 8 inches instead of the higher end methods. Now that's the raw QPF if you take a 10 to 1. If you do other ratios here, if you change this, I guess 11 to 1, but if you change this to like 13 to 1, 14 to 1, certainly you're going to see higher values. The Cobb method, you can see the values here, the dashed lines, they're giving us a little bit more snow because the max temp in the profile through most of this event is actually pretty low, relatively speaking. So maybe the ratios can combat a little bit of the decrease in QPF that I think we might see over the next couple of model runs. But again, for the most part, look at the nice agreement between the models here at DuPage. Taking you other places, here's O'Hare. Plume at O'Hare, again, sort of average here, right around an inch of QPF. We've got sort of some values here from the 4 kilometer that are pretty eye-popping, but that might be catching in on a little bit of lake enhancement as well. Some of the things that the models like the GFS and the NAM generally won't be able to pick up on. And the Weather Service forecast of QPF right around 0.8 or so. And again, I think a great idea here is to just sort of split the difference in the all of the models go with an average perspective here, and O'Hare, an average perspective probably puts you around 10 inches, and you can see some train off in the amounts as compaction begins to play a role. Since this is a really long duration event, unless you're taking observations and measurements every hour, your values might differ quite a bit depending on where you're located, because this compaction could play a role. So if you'd only measure every 6 hours versus every hour, I'm guessing we might see some different values depending on the method of observation used. I'm going to try to take observations every hour from this particular system just to get an idea of how much snow is falling without the effect of compaction. Going downstate here a little bit, here's Peoria's precipitation accumulation. Again, because we're not seeing frontogenesis from this particular system, or at least not a lot of it, you're not going to see highly variable snow amounts or even sort of QPF values. I'm going to show you. I could show you that here if we go back to the NAM, the accumulated QPF over time. A lot of the area sees a pretty general swath of around 1 inch to 2 inches. So again, it's sort of accounting for this idea of the precipitable water that's currently available in the atmosphere. I like the idea of the Weather Service shading a little bit lower. But still, recognizing that the ratios might be able to make up for that. So if you're in Peoria here, expect on average somewhere around 8 inches in yourself. You can give yourself a range here, right? Anywhere from 6 on the low end to maybe 10 on the high end, depending on how much actually falls as snow. Rockford, a little bit further north, will probably see a little bit less QPF on average here, maybe around 0.7, 0.6 area. But you will have colder temperatures that will allow you to probably achieve about the same snowfall as places further south, because your temperatures are going to be a little bit lower during this particular event. And finally here's the 4 kilometer version. This is just one run of one model idea here, but most of them are sort of saying the same thing, so you can sort of jump on board with these high resolution model outputs at this point. The purple here is showing you, if I take a look at the scale here at the bottom, or maybe the scales at the top, there we go. So I think these are in let's see here, probably inches with a decimal is coming out here is what I'm seeing. So the whites showing up near O'Hare, probably sort of 14-inch range. The purples, 10-inch range here. The first purple crossover is 6 inches. So if you take a look at this map, anywhere you see purple or greater, so these darker purples, even whites, that's the swath of at least 6 inches of snow. So you can see that's quite great. Highest value showing up around the I-80 corridor. Again, is we sort of expected that. But I wouldn't be quite surprised to see some values of 10 inches across most theaters. So in general here across northern and northeast Illinois, expect a good 6 to 10 inches across most of the area. Possible higher amounts, but I'm sort of not seeing those values of certainly 14 inches at all, unless you're right near the lake and you're seeing some nice lake enhancement. I don't see those sort of totals panning out. I'm going to go back here just quickly so I can show you the QPF output from this as well. So just go to precipitation accumulation very quickly, and then we'll finish up here. The swath of QPF, again, not sort of really highly variable amounts, sort of a nice change as we go further downstate. And again, some of this might actually be liquid, especially in the southern end. So I'm still expecting, certainly 1.67. You multiply that by 10, you think 16 inches, but with the lake enhancement, I guess that is possible. But again, I think the QPF values might be a little bit overdone given what we're seeing in the precipitable water field here this morning. So I'm going to sort of just chalk this up to probably 1.5 inches downstate QPF, more of like 1 inch QPF over most of the I-88 corridor, giving us probably around 10 inches. Here in Kane and DuPage counties, and as you get further in towards the lake, you might see a little bit higher values from the lake enhancement. But But again, generally speaking, I think this is going to be a pretty significant snow for most of northern and central Illinois, northeast Illinois, and especially as you get into northern Indiana. And you can see those snowfall totals as you get over here by 60 hours, 1.41, and the ratios by that time are actually a little bit even more impressive. So the big snow totals might end up sort of right in here where I'm circling with my mouse by the time this is all said and done. So I hope you enjoyed the briefing. We'll see. It'll be fun to watch how this particular forecast pans out. And when we start to get the snow totals in here, we'll be able to look at a little bit of a verification for this forecast. Thanks for listening.